Hey everyone, today we'll be looking at the first lesson of Unit 4, which is going to be going through volume and capacity, and we'll also be going through temperature as well. So we'll start off with going through the volume and capacity lesson and then get to the temperature. Now, one way to think about capacity is the maximum amount that a container can hold. So how much can you fit inside of that container? In the SI, so System International, the base unit for measuring volume is the liter. So this is our base unit that we're going to use. And the liter is also the base SI unit for measuring capacity as well. In Canada, we use the term imperial units to mean British imperial units. The United States also uses imperial system, but the sizes of its units for volume and capacity are different from the British units. So for example, the British pint is 20 fluid ounces, while the US pint contains 16 fluid ounces. Now, we have a chart set up below to help you out with this. So we have on the left-hand side the unit and then their abbreviation. So we have ounces is OZ. We have fluid ounces is FLOZ. Then we have pint is PT, quarts is QT, and gallon is GAL. And then we also have the conversion for the US imperial to SI units. So we have 1 fluid ounce equals 29.5735 milliliters, and so on. I'm not going to read through all of these just because it's going to be repetitive and you have it right in front of you. But this is where we're going to kind of start as our foundation and always refer back to as our reference when we're working with these conversions. Now, important though is we have the US and SI right here, and then we have our British Imperial and SI. So remember that those are going to be different. So depending on the question you're working with, pay attention. Is it talking about the British Imperial? So then you have to make sure you're using that table to calculate the value correctly. Below that is converting common cooking units. So if you're taking foods right now, this may be something that you've worked with before. If you've just worked in the kitchen and you've been baking, for example, using different teaspoons, tablespoons, cups, and so on, you might be familiar with this a little bit. But if not, we have the conversions here. So we're looking at teaspoons to milliliters, tablespoons to milliliters, cups to milliliters. So we have all the conversions laid out for us. Now, one thing to notice is some are inconsistent. So 1 cup is usually 236 milliliters, but we round that to 250 milliliters. So for example, here, we round it up to 250 milliliters, especially for stuff like baking, because it's going to be an easier unit of measure rather than trying to go to 236.59 milliliters. So when we're doing cooking or conversions this way, we're going to be using this method here where we're using these values that we've given you. So we're not using those exact values always. That's also why now often in cooking, they use a scale instead of using measuring cups to make sure that you are using the exact amount. Now, moving on to the second page, we have example 1 where we're looking at converting the following recipes. So we have 3 cups of flour and we want to put this into milliliters. Well, if we think back to this page here, we have 1 cup equals 250 milliliters. So we have 3 cups and we want to take this and multiply it by 250 and we're going to get 750 milliliters. Next, we have 1.5 teaspoons of baking soda. Well, if we look back, 1 teaspoon is 5 milliliters, and we have right above that is half a teaspoon, which is 2 milliliters. So we're going to go with 5 plus 2 equals 7 milliliters here. Or half a teaspoon of salt. If we want to find out half a teaspoon of salt, well, we just use that above. It's going to be 2 milliliters. Now, the rest I'm going to leave for you to figure out on your own, and then make sure you're checking the OneNote so that you know that you've got the correct answers. Now we're going to move on to our first word problem. So we have Nigel imported a vehicle that was made in Britain. The capacity of the gas tank is 22 gallons. Now, think about it's made in Britain, so we're going to have to factor that in when we're doing our conversions. If the price of gasoline is $1.20 a liter, how much will it cost Nigel to fill his tank when it is completely empty? So what we want to think about or look back to is, what is our conversion for British Imperial into liters? Well, we're going to look back here, and we have 1 pint equals 568. We don't want to use that, but we do want to use 1 gallon. It equals 4.5461 liters. So we want to use that conversion here when we're looking at going from gallons to liters. So what we're going to have to do here is we're going to have to set up a cross multiplication. We have 1 gallon over 4.5461 liters equals, now we're going to have to set up our cross multiplication, so I'm going to put in my line here, and I have 22 gallons, so 22 gallons, and we want to figure out how many liters this is going to be. So we've set up our cross multiplication. That means that this is going to cross, this is going to cross and multiply. So we have 1 multiplied by x, which is going to give us 1x, equals 4.5461 multiplied by 22. This is going to give us 100.0142 liters. So this is how many liters we're going to get for our British Imperial conversion. Now, we're not done here because we first found out how many liters we have, but we have to figure out how much is it actually going to cost. Well, we look up here and we're paying $1.20 per liter. So $1.20 per liter, and we have 100 and a bit liters to fill up this gas tank. So we have to take our price, which is going to be equal to $1.20 per liter multiplied by 100.0142, and we're going to find out to fill up our gas tank from completely empty, it's going to cost us $120.02. And remember, we're always going to 2 decimal places because we are dealing with money here. In example 3, we have Paula is opening a French bakery and wants to make authentic French recipes. All of the recipes are given in metric units, but she has imperial measuring devices. A creme brulee recipe requires 500 milliliters of cream and 1.25 milliliters of vanilla. So how much cream will she need in 1 cup? So we require 500 milliliters of cream, and we want to figure out how many cups this is. If we flip back, we're going to find out that 1 cup is equal to 250 milliliters. Well, we can set up our cross multiplication and draw our line and think about, what do we know? Do we know our cups or do we know our milliliters? Well, if we're trying to find out our cups, that's where X goes. And then that means our 500 milliliters goes on the bottom. Most important thing when you're doing cross multiplication is the same unit of measure is beside each other. So if cups are on top, cups stay on top. If milliliters are on the bottom, milliliters stay on the bottom. So we have 500 milliliters on the bottom. Now we've set this up, we can do our cross multiplication and figure out, well, this is going to be 250 multiplied by x, so we'll get 250x equals 1 cup multiplied by 500 is going to give us 500. Well, we have 250x equals 500, and we want to get x by itself. In order to get x by itself, we have to divide it by our 250. And what we do to one side, we do to the other. So divide by 250, giving us x equaling 500 divided by 250 is 2 cups. So our final answer is going to be 2 cups for 500 milliliters. So 500 milliliters equals 2 cups when we're measuring. Next, we have how much vanilla will she need in teaspoons? Well, if we look back up, we have 1.25 milliliters of vanilla. So we have 1.25 milliliters of vanilla. First thing we need to think about is what is our conversion. So our conversion, if you look back to your first page, is going to be 1 teaspoon is equal to 5 milliliters. So we have teaspoons on top and milliliters on the bottom. We're trying to find out teaspoons, so that means that's where my x is going. And we want to use the amount of milliliters we have, which is 1.25 milliliters, making sure teaspoons are on top, milliliters are on the bottom, milliliters are on the bottom. Now we can cross multiply. So we'll have 5 multiplied by x, giving us 5x is equal to 1 multiplied by 1.25, which is 1.25. We want to get x by itself, so divide by 5. And you have to do that to the other side as well, so divide by 5. That cancels it off there, leaving us just with x. And we have 1.25 divided by 5, which will be 0.25 of a teaspoon. Now, another way to think about this would be in fractions. If we had 0.25 of a teaspoon, this would be the same as saying we have a quarter of a teaspoon. So that would be the same thing. So they're both equal to each other. So you could write 0.25 teaspoons, or you could write a quarter of a teaspoon. Now the last thing is we want to figure out how much cream she will need in fluid ounces. Well, we have to again think about what is our conversion. We want to find out how many fluid ounces total of cream, and we have 500 milliliters of cream. So we have 500 milliliters of cream, and we also know that that was equal to 2 cups of cream. Well, if we go back to our original page, we can look up here and find that 2 cups is equal to 16 fluid ounces. So looking at this table here, just for further clarification, 1 pint is equal to 16 fluid ounces. 16 fluid ounces is equal to 2 cups, which also means then that 1 pint is equal to 2 cups. So all of these are equal to each other. It also means that 1 pint is equal to 473.176 milliliters, and 1 pint is equal to 0.473 liters. So 16 fluid ounces is equal to 473.176 milliliters, and it's also equal to this amount of liters. 2 cups is equal to this amount, and 2 cups is equal to this amount. So the way that we have this set up is that there's a lot of different conversions here organized into a small table. So what we're worried about though is our 2 cups, and we know that that is equal to 16 fluid ounces. So we can go back and finish this part off, that 2 cups is equal to 16 fluid ounces. And that would be our final amount for the number of fluid ounces of cream. Now we're going to take a look at temperature. So we're moving away from volume and capacity, and we're looking at temperature. Temperature is measured using a thermometer that may be calibrated to a different scale. In Canada, the temperature is measured using the Celsius scale, but there are some cases where the Fahrenheit scale is also used. Now, this is most often used in the States. Prepare a temperature graph. So we want to look at what these numbers are equivalent to between Fahrenheit and Celsius. So, for example, on a bitter cold day, which would be minus 22 Fahrenheit, here we'd be looking at minus 30 degrees Celsius. So that would be on a really cold day. On a mild day, so not too bad out, it would be equal to 59 degrees Fahrenheit, which is 15 degrees Celsius here. 81 degrees Fahrenheit, which would be on a hot day, would be 27 degrees Celsius here. Your body temperature in Fahrenheit should be 98.6 degrees if you're healthy, and 37 degrees Celsius if you're here using the Celsius scale. And boiling water, well, water is going to boil at 212 degrees Fahrenheit or 100 degrees Celsius. So these are just a point of reference, just so when you're trying to think about any of the problems that you come up with, what your approximate temperature should be when you're converting back and forth. So you can always use this as a guide to see if your answer is on the right track. Now below here, it says what type of relationship appears to exist between the 2 temperatures. Well, if we look at this line here to look at what type of relationship it is, it's a straight line. Whenever we're talking about a straight line in math, we're going to talk about it being a linear relation. So a linear line means that it's going to have a constant rate of change. So it's changing consistently by the same amount each way. If we look at the following temperatures, so using the graph, determine the approximate Fahrenheit. So if we have 20 degrees Celsius, we want to figure out the approximate temperature in Fahrenheit. Well, degrees Celsius is on the bottom here. So if we go up from 20, it's going to reach right here. And then we want to figure out in Fahrenheit, so we want to make our line right across, and it'll connect right there. So we can guess that this is going to be approximately 68 degrees Fahrenheit. If we go up from 40 degrees, so we go straight up from 40 degrees, we're going to find that this line here is approximately, now remember I'm not using straight lines, I'm just doing an approximate. It's going to be approximately 104 degrees Fahrenheit. 60 degrees, well, we go all the way up 60, which is going to bring us right to here. And then we want to go straight across. Well, that's pretty much right on that line there. So it's going to give us to approximately 140 degrees Fahrenheit. And last, we have 80 degrees Celsius. Well, 80 is here. We go all the way up. It's going to bring us right to here. And if we bring our line across, it's going to fall somewhere right around here. So this will be approximately 176 degrees Fahrenheit. So that's just using our graph to approximate what the difference between Celsius and Fahrenheit would be. Now, each pair of Celsius temperatures above differs by 20 degrees Celsius. What do you notice about the Fahrenheit? Well, let's have a look. This is differing by 20 degrees Celsius each time. So changing by 20 degrees Celsius, changing by 20 degrees Celsius. Well, if we do 104 subtract 68, we're going to find that this changed by 36 degrees Fahrenheit. And do 140 subtract 104, again 36 degrees Fahrenheit. And 176 subtract 140, we're going to find that this again is 36 degrees Fahrenheit. So every time we change by 20 degrees Celsius, we're changing in Fahrenheit by 36 degrees. So, going to answer this question on the second page here, the degrees Fahrenheit differs by 36. For question 4, it says, how can you use the graph to determine the degrees Celsius that corresponds to a given Fahrenheit temperature? Now, there's going to be two different terms we're going to use to determine how we're going to find this. Now, the first one we're going to talk about is interpolate. Interpolate is going to be finding something fixed between two spots on the graph. Now, this is going to be inside of what you know, so inside of the data you already have. Extrapolate is going to be assuming trends continue and are consistent so that they are linear, and it's going to be outside of the data that you know. So if we're looking back here, interpolating would be looking at anything inside this line here, where extrapolate was going to be outside if we're continuing on either way. So use the graph to determine the approximate Celsius equivalent for -10. Well, if we go back onto this graph, we want to look at where -10 is going to be. Well, -10, we want to approximate that it's going to be about there on the graph. If we think that this line is going to extend straight down, now that is not a beautiful straight line, but it's just giving us an idea right now. And then we can go up to figure out where approximately our -10 would meet, and it would be safe to assume that it's going to meet approximately around 13-ish, 14-ish degrees. But we can also take this a little bit further and do some math behind this to figure this out. So let's do the math because it's going to be more accurate here. If we know that for each 20 degrees, it's going to change 36 degrees Fahrenheit, which we found out in question 3 here. So every 20 degrees Celsius, it's 36 degrees Fahrenheit. In order to increase by increments of 10 degrees Celsius, which we're trying to look for eventually, -10 degrees Celsius, we want to figure out what the change is in Fahrenheit for every 10 degrees Celsius. So what we'd have to do is take our 36 degrees Fahrenheit and divide it by 2 and figure out that 18 degrees Fahrenheit is going to be the change for every 10 degrees Celsius. So if we are looking at -10 degrees Celsius, well, one thing we know is 0 degrees Celsius, which is the freezing point, is equal to 32 degrees Fahrenheit. So that's going to give us a starting point. If 0 degrees Celsius is 32 degrees Fahrenheit, we can work backwards by knowing that -10 degrees Celsius is going to be equal to 32 degrees Fahrenheit, subtract 18 degrees Fahrenheit, because that's our change in Fahrenheit for every 10 degrees Celsius, and we're going to -10, so that's why we're subtracting 10. So we're subtracting 18 as well. So that means that 32 subtract 18 equals 14 degrees Fahrenheit. So our estimation using our extension of the line, so extrapolation of the line, to figure out that it was approximately around 14 degrees Fahrenheit was pretty right on. So 14 degrees Fahrenheit is what we get when we're actually doing the calculation to figure out what -10 is. Now, using the fact that 0 degrees Celsius and 100 degrees Celsius are the freezing and boiling points of water, respectively, on the Celsius scale, and that corresponds with the temperatures on the Fahrenheit scale of 32 degrees Fahrenheit and 212 degrees Fahrenheit, develop a formula for converting degrees Fahrenheit to degrees Celsius. Now, we're going to go through the process of actually creating the formula that we're always going to use throughout this unit for converting from Fahrenheit to Celsius. So, based off of 0 degrees Celsius equaling 32 degrees Fahrenheit and 100 degrees Celsius equaling 212 degrees Fahrenheit, difference in Celsius of 100 degrees, and we have a difference in Fahrenheit of 180 degrees. So that's going to help us figure out what our conversion is going to be for converting from Celsius to Fahrenheit. So Celsius over Fahrenheit, well, equals our difference of 100 degrees over our difference of 180 degrees. Now, if we wanted to reduce this, we could divide the top by 20 and divide the bottom by 20, which would show us that we'd get 5/9. So 5 over 9. What that means is for every degree Fahrenheit, it is 5/9 of a degree of Celsius. So 1 degree Fahrenheit is 5/9 a degree of Celsius. Now, we're going to put this into a formula to figure out how to switch back and forth. So Celsius equals 5/9 a degree of Fahrenheit. And another piece of information, we know that at 0 degrees Celsius, it is 32 degrees Fahrenheit. So that's going to come into play in our formula, where it's going to be in brackets, the amount Fahrenheit, subtract 32, and close the bracket. So this is the same as if we wrote it out as Celsius equals 5 times, in brackets, Fahrenheit, subtract 32, closing the brackets, and then dividing this all by 9. And F in the equation is going to be your Fahrenheit. So this is the equation you would use from going from Fahrenheit into Celsius. We do Fahrenheit, subtract 32, and then we'd multiply that by 5 and divide it by 9. Though, when we're looking at going from Fahrenheit into Celsius, we have to use a different formula. And this formula is going to be F equals 9 over 5. So we're reversing the fraction, or we're flipping the fraction. And then we have C plus 32. So we're doing the opposite. Instead of subtracting 32, we're adding 32. And instead of having 5 over 9, we're flipping that over and we have 9 over 5. So this would look like Fahrenheit equals 9 times my Celsius divided by 5, and then adding 32 on. Now let's use these equations in these practice questions below. So for the first one, we have, while visiting Florida, Kathy heard a local person say that it has been very cold overnight and it has only been 42 degrees. At first, she thought that it was not cold, but Kathy realized that the person meant in degrees Fahrenheit. So we have 42 degrees, but never specified if it was Celsius or Fahrenheit. Now, obviously in Celsius, that would be quite warm, but in Fahrenheit, let's figure out what that's going to be. So if we have 42 degrees Fahrenheit and we want to figure out what in Celsius it's going to be, we want to use our equation that we came up with on the other side. So we have Celsius equals 5 times my, in brackets, Fahrenheit subtract 32, closing the brackets, divided by 9. We have Celsius equals 5 times, in brackets, our Fahrenheit, which is 42, subtract 32, and then closing the brackets. Then we have this all divided by 9. So your first thing you want to do is we want to deal with the 42 subtract 32. So we want to follow BEDMAS and follow our order of operations. So we have C equals 5 times, we have 42 subtract 32, leaving us with 10, closing the brackets, dividing by 9. Now we have C equals 5 times 10, which is 50, divided by 9. So C equals 5.6 degrees, no, that's in the wrong spot, degrees Celsius. So 42 degrees Fahrenheit is going to be equal to 5.6 degrees Celsius. That would be quite cool. So when you're talking about temperature, it's really important that you list if it's Fahrenheit or Celsius so that they know exactly what you're talking about. In the next question, you're going to be looking at 48 degrees Celsius and converting this to Fahrenheit. So I'm going to leave this one for you to complete on your own, and I want you to check the OneNote once you've completed it. Other than that, if you have any questions, send me a message in Teams, and have a great day.